Good morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today's our topic name is Random Forest. In previous class, we have seen that attribute selection measures in decision tree. Actually, in that, we have seen that if we have got the overfitting in the decision tree, then how we can avoid by using the pruning and by using the random forest method, we can avoid our overfitting method. We can avoid overfitting method. But what is meant by pruning? Pruning means just you will remove the unwanted branches from your tree. That's it. So, and another method is that the random forest. So, today we will cover this random forest and we will cover these topics: introduction, then working of random forest algorithm, features of random forest, classification in random forest, regression in random forest, and application of the random forest. So we will see one by one. First, introduction. Random forest. What is meant by random forest? Actually, random forest is a supervised machine learning algorithm that used widely in classification and regression algorithm. You know that the supervised machine learning algorithm means we will give the training to our models and then we will get the results. Here also in random forest is one of the supervised machine algorithm where we will use both the problems like classification and the regression, and it builds the decision trees on the different samples and take their major vote for classification and average in case of regression. So actually random forest builds some decision tree on the basis of different samples, and again on the basis of the vote for classification, then again average in case of the regression. And one of the most important feature of the random forest algorithm is it can handle that the data set containing continuous variable, as in the case of regression, categorical variable, as in the case of classification. That means if you are using the regression problem, so at that time you can use the continuous variable and you have to use the continuous variable for handling your data set. And if you are using the classification problem, so at that time you have to use the categorical variable for maintaining your data set. So both problems are occurred in the random forest, like classification and the regression problem, and both are using some variables for maintaining the data set, and it performs the better results for the classification problems. And on that basis, on the classification of basis, we can say that random forest is a classifier that contains several decision trees on the various subsets of the given dataset and take the average to improve the predictive accuracy of that dataset. That means random forest is definitely it's your classifier. So that classifier is containing some decision trees, and that decision trees are totally depends on your subset of the given dataset. Sometimes you can take the average for improving your predictive accuracy, improving your predictions of the data set. And it is based on the concept of ensemble learning, which is a process combining multiple classifiers for solving your complex problem and for improving the performance of the model. Now we will see the types of machine learning. Which type of machine learning we will use in the random forest? So for better understanding the random forest algorithm and how it is working, so it will that some machine learning algorithms will very helpful. First one is the reinforced learning, unsupervised learning, and the supervised learning. And you know that random forest is a supervised learning model. So every time we have to give the training to our models, and after that we will get the results. So what is meant by reinforced learning? Actually, it is the process of teaching a machine for making the specific decisions using the trial and error. So here you will teach that particular system will teach to machine for making us some particular decisions. Then unsupervised learning, users have to look at the data and then divide it based on its own algorithm without having any training. There is no target or outcome variable to predict nor estimate. That means in unsupervised learning, there is no need to give the training to your model. So without giving training to your model, you can get any result. And even there is no any target or outcome variable for prediction or for estimation of the results. Then supervised learning. Supervised learning, users have a lot of data and can train your model. That means if you have a data set, then definitely you have to train your model, and on that basis you will get the result. Supervised learning further fall into again two types. That groups are, one is the classification and another one is the regression. And with the supervised training, the training data can contain the input and some target values. That means we can say that output. And the algorithm generally pick up the pattern that map the input value to the output and uses this pattern for predicting the values in the future. Generally, in this algorithm, your algorithm will pick up some of the patterns, and that pattern will map some of the input values into the output values, and you will use this pattern for prediction some values. The unsupervised learning, on the other hand, uses training data that does not contain the output values, and algorithm figures out the desired output over multiple iteration of the training. Finally, we have reinforced learning. The algorithm is rewarded for every right decision made, and using this as a feedback, the algorithm can build stronger strategies. Actually, in reinforced algorithm or reinforced learning, it will help to take a particular decision by using the feedback, and this algorithm will use a particular and strongest strategies for giving the output. Now, what is the real life analogy? Which real life analogy we will use in the random forest? Let's dive a real life analogy for understanding the concept. For a student named X wants to choose a course after his intern, and he's confused that now what he should choose and on what skill basis he has to choose. So he decides to consult various people like cousins, teachers, then parents, degree students, then working people. That means that particular students wants to choose one of the stream on the basis of the skill set. So after that, for this purpose, for reaching particular decision, he contacted to another person, so many persons, like we can say cousin, teachers, again he contact with parents, then degree students, working people. So he asked everybody different questions, like why he should choose then what are the job opportunities with that particular course, then what is the particular course fee. And finally, after consulting various people about the course, he decided to take the course suggested by most of the people. That means in real life also same thing is happening. And after communicating so many people, he decided that he will choose one of the course. And one of the course means which course? Only though that course those people suggested so many people. That course who are suggested so many people. So this is your real life analogy. Here various people act as an individual decision. Various people, then question asked by him perform the activity of the decision tree, and the final decision acts as a final output based on the majority output. So here definitely particular person wants to take the decision. On for taking that decision, he asked so many person some of the questions, and after that he has chosen one of the final output on the basis of the majority voting. Then how it will work? How random forest algorithm is working? So before understanding the working of the random forest algorithm in machine learning, first we must look into the ensemble technique. What are the ensemble technique? Ensemble is simply means combining your multiple models. Here you will combine your models together, and thus a collection of models generally is used for making a prediction rather than an individual model. Ensemble uses two type of method. One is a bagging and another one is a boosting. Now we will see one by one. Actually bagging will create different training subset from sample training data with the replacement, and final output is based on majority voting, for example random forest. In bagging what will happen? It will create different training subset from different sample data set with the replacement, and final output will be based on majority of voting. Again the example is a random forest, and the boosting is it will combine the weak learning into strong learner. How it will combine? By creating the sequential models, like we can say the final model has the highest accuracy. For example, ADA boost, XG boost, these are boosting techniques. So by using these techniques, we will combine our learners, weak learners into the strong learner. So we can create the sequential model for getting a output with the highest accuracy. So what is meant by bagging? You can see here bagging concept will be work like parallel, and the boosting will work sequentially. Now we will see in detail bagging. Bagging is also known as a bootstrap aggregation. It is ensemble technique used by the random forest. Actually, this bagging chooses a random sample from the dataset. Here, each model is generated from the sample which is provided by original data with the replacement. That replacement we will call the row sampling. This step of row sampling with replacement is called the bootstrap. Now each model is trained independently, which generate the results also independently, and the final output is based on the majority voting after combining the result of all model. And this step, which involves the combining all the result and generating the output based on the majority voting, which is known as aggregation. Now bagging, this is your original data. Now you have applied the bootstrapping technique, and then after that you have aggregated your data. By using the ensemble classifier, you have find out particular result for the set of the data. Now let's look an example by breaking it down with the help of the following figure. Here the bootstrap sample is taken from the actual data. You can see here bootstrap data is taken from original data or actual data, we can say bootstrap sample 1, bootstrap sample 2 and bootstrap sample 3. And this data we took with a replacement. That means here the high possibility is that each sample won't contain the unique data. Now the model, that means model 1, model 2 and model 3. These models are obtained from the bootstrap sample is trained independently. Now each model generates the result as shown. Now happy emoji is having majority when compared to sad emoji. Here you can see. Then thus based on the majority voting, final output is obtained as a happy emoji. Now we will see bagging ensemble method. Again actual data. Now you have used a bootstrap sample 1, bootstrap sample 2, bootstrap sample 3. Model 1 you have created model 1, model 2 and model 3. And by using the majority of voting, you got the happy emoji. Now which steps you have to follow in random forest algorithm? Step 1. In random forest, n number of random forests are taken from the data set having k number of records. Then step 2. Individual decision trees are constructed for each sample. Then step 3. Each decision tree will generate an output. And step 4, final output is considered based on the majority voting or averaging for classification and regression respectively. That means in step 1, you have a number of records. On that basis, you will take the individual decision from particular model, and after that each decision tree will generate some of the output, and final output will be considered as based on the your majority of voting. Now this is again tree 1, tree 2, tree n. This is your class 1, class 2 and class n, and on that basis majority voting for classification or averaging for regression, that means final class. Then after that, for example, consider the fruit basket as the data as shown in figure below. This is your diagram. Now n number of samples are taken from the fruit basket and individual decision tree is constructed for each sample. You can see here, we have taken n number of records, n number of samples from the fruit basket, and on that basis we will find out the sum of the result and we will construct the decision tree. Each decision tree will generate output. Here you can see every decision tree has generated the output as tree 1 class A, tree 2 class A and tree n class B. In the below figure, you can see that majority decision tree gives the output as apple when compared to banana, so the final output is taken as an apple. Class A showing for apple, class A tree 2 also showing for apple, but class B tree n is showing for banana. That means when majority voting is for apple, that's why its a final class will be your apple. Now there are some features of the random forest. First one is diversity. Not all attributes, all variables or features are considered while making an individual tree. Each tree is different. Second one is immune to the curse of dimensionality. Since each tree does not consider all features, the feature space is reduced. Then third one is parallelization. Each tree is created independently out of the different data and attributes. This means we can make full use of CPU to build the random forest. First one is a diversity. That means we will not consider all attributes, all variables and features for making individual tree. Then second one is immune to the curse of dimensionality. Here each tree will not consider for all features. It will not consider all features because some features can be reduced. In parallelization, each tree will be created independently output for different data, different outputs. So that means We can make full use of the CPU for building some random forest. Then fourth one is train test split. In random forest, we don't have to segregate the data for train and test, as there will always be 30% of data which is not seen by the decision tree. Then stability. Stability arises because the result is based on the majority voting or averaging. That means there are main 5 features: diversity, immune to the course of dimensionality, parallelization, train test split, and stability. Now, there are some important hyperparameters. What are mean by hyperparameters? The actually hyperparameters are used in random forest to either enhance the performance and predictive power of models or to make the model faster. By using these hyperparameters, we can make the faster our model. Then we can enhance the performance of your model. We can enhance the predictive power of the model. So there are some hyperparameters which are increasing the predictive parameter. First one is an estimator. The number of trees algorithm builds before the averaging the predictions. Second one is max feature. That means maximum number of features random forest consider the splitting a node. N estimator, it will build before averaging the prediction. Max feature, it will consider the splitting nodes. Then third one is mini sample leaf. It will determine the minimum number of leaves required to split an internal node. Then there are some parameters, hyperparameter, which are increasing the speed. First one is n job. These parameters were n estimator, max feature, and mini sample leaf. These hyperparameters are used for increasing the predictive power of your model. Now, n job, random state, and OOB score are used for increasing the speed of your model. N job means it tells the engine how many processors it is allowed to use. That engine, how many processors it will allow. So this will explain by the n job. And if the value is 1, that means it can use only one process. But if the value is -1, there is no limit. Then second one is random state. Random state saying that it controls the randomness of the sample. The model will always produce the same result if it has a definite value of random state and if it has given the same hyperparameters and the same training data. Random state, it will produce the same result after giving the training to your models. Then next one is OOB score. OOB score means out of the bag. It is the random forest cross-validation method. In this, 1/3 of the sample is not used to train the data instead of using to evaluate its performance. And these samples are generally called as a out of the bag sample. Now there are difference between decision tree and a random forest. Decision trees generally suffer from problem of overfitting, and if it is not allowed to grow without any control. That means I already told that in decision trees most of the time overfitting problem can occur. So if overfitting is occurred in your decision tree, so after that your decision tree will not grow. It can't work properly. And in random forests are created from the subset of data. And the final output is based on the average or majority of ranking, and hence the problem of overfitting is taken care of. That means in random forests, overfitting will be avoided totally. So there is no chance of occurring the problem of the overfitting. Why? Because of we are taking the decision on the basis of the majority ranking, majority of voting. So that's why overfitting problem will not occur in the random forest. Then decision tree. A single decision tree is faster in the computation, and random forest it is comparatively slow. Decision tree is always faster as compared to the random forest. When the data is set with feature is taken as input by the decision tree, it will formulate some of the set of rules to do prediction. And the random forest randomly selected observation builds decision tree, average result is taken. It doesn't use any set of formulas. But in decision tree there is need to use the set of formulas, and in random forest there is no need to use the set of formulas. You can take a decision on the basis of directly majority of voting. Now there are some classification in random forest. Actually, classification in random forest employs an ensemble technology to attain the outcome. The training data is fed to train various decision tree. Then this dataset consists of observations and features that will be selected randomly during the splitting of the nodes. That means in classification what we will do, we will classify our nodes, we will split our nodes, and we will give the training to our data, and the training data is fed to train various decision tree, and the rainforest system relies on various decision tree. Every decision tree consists of decision node, leaf node and root node, and the leaf node of each tree is a final output which is produced by the specific decision tree, and the selection of the final output follows the majority of voting. And in this case, the output chosen by the majority of decision tree, it becomes the final output of the rainforest system. The diagram below shows the simple random forest. See, there is a random forest classifier. One of the main root is dataset. Again, they have two branches. There are three branches. One decision tree. This is your decision tree, another decision tree, and this is another third one decision tree. So, on that basis, for example, this is your prediction 1, this is your prediction 2, and this is your prediction 3. So, when majority vote taken, so after these predictions, we will get the majority votes, and on that basis, we will find out our conclusion. This will be our conclusion. This will be our result, or we can say it is your result. Let's take an example training data set consisting various fruits such as bananas, apples, pineapple and mangoes. The random forest classifier divides the dataset into subsets. These subsets are given to every decision tree in the random forest system, and each decision tree produces specific output. For example, prediction for trees 1 and 2 is apple. Prediction 1 and prediction for tree 1 and for tree 2, there are prediction for as an apple. And another decision tree N has predicted banana as the outcome. The random forest classifier collects the majority voting for providing the final prediction. And the majority of decision tree have chosen apple as their prediction, and this makes the classifier choose apple as the final decision. Now this is our data set instances. Then we have n number of decision trees, and so many trees gives the output as a apple, and the remaining trees give the output as a banana. But majority of voting is saying that it is a apple. So that's why your final class will be apple, and This is your main classifier in the random forest. Now we will see regression in random forest. Regression is the other task performed by random forest algorithm, and a random forest regression follows the concept of the simple regression. The values are dependent and independent variables generally passed in the random forest model, and we can run the random forest regression in various programs such as SS, R and Python. And in random forest regression, each tree will produce some of the prediction, and the mean prediction of the individual tree is your output of the regression, and this is the contrary to random forest classification whose output is determined by the mode of the decision trees class. And although the random forest regression, linear regression follow the same concept, and they are differing in terms of the function. And the function of linear regression is that y is equal to bx plus c, where y is your independent variable, x is independent variable, and b is your estimation parameter, and c is your constant. And the function of the complex random forest regression is like black box. Now we will see the applications of random forest. There are so many departments, so many fields where we are using the random forest. First is a banking. Random forest is used in the banking for predicting the credit worthiness of a loan applicant. Then it will help the lending institutions make a good decision on whether to give the customer loan or not. And then banks also use the random forest algorithm for detecting the fraudsters. Then second field is healthcare. Health professionals use random forest system to diagnose the patients. And the patients are diagnosed by assessing their previous medical history, and the past medical records are reviewed to establish the right doses for the patients. Then next one is stock market. The financial analysts use it for identifying the potential markets for stocks, and it also enables for them to identify the behavior of the stock. Next one is e-commerce. Through rainforest algorithm, e-commerce vendors can predict the preference of the customer based on past consumption behavior. That means these are applications of the random forest. There are main applications of random forest: banking, healthcare, stock market, and the e-commerce. Then when to avoid using the random forest? Actually, there are two conditions like extrapolation and the sparse data. Random forest algorithm are not ideal in the following situation. We can't use in the following situation like extrapolation and the sparse data. First one is the extrapolation. The random forest regression is not ideal in the extrapolation of the data. Unlike linear regression, which uses the existing observation for estimating the values beyond the observation range. And this explains why most application of the random forest relate to the classification. And you know that your random forest is totally related to your classification and the regression method. And another method is sparse data. Random forest does not produce good results when the data is very sparse. In this case, the subset of the features and the bootstrap sample will produce an invariant space. This will lead to unproductive splits which will affect the outcome. Now there are some advantages of the random forest. It overcomes the problem of overfitting by averaging or combining the result of different decision tree. Then second one, the random forest work well for a large range of the data item than a decision tree does. Then random forest has less variance than single decision tree. Random forests are very flexible and possess very high accuracy. Scaling of the data does not require in random forest algorithm, and that's why it can maintain the good accuracy even after providing the data without the scaling. Random forest algorithm maintains good accuracy. Even the large proportion of the data is missing also, it will provide the accuracy of the data. Then there are disadvantage of the random forest. When using the random forest, more resources are required for the computation. It consumes more time as compared to decision tree algorithm. Then complexity is also, it's a main disadvantage of the random forest algorithm, and the construction of the random forest are much harder and time consuming than the decision tree. More computational resources are required for implementing the random forest algorithm. Then it is less intuitive in case when we have a large collection of the decision tree, and the prediction process also using problem forest, a random forest, which is very time consuming in the comparison with another algorithms. So this is all about the random forest. These are your references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.